So this video is an answer key to the 3 triangle problems that you were asked to complete. Based on the GeoGebra sketches, I'll begin with triangle K. The equilateral triangle not only does it have 3 equal sides, but also has 3 equal angles. And again, based on the sketch, and all these angles are 60 degrees. So that would be the answer for the 3 angles for problem K. In problem J, one with the 2 equal sides, which is an isosceles triangle. The isosceles triangle always has at least 2 equal angles. So one way of identifying the equal angles is also to think about an isosceles triangle having a line of symmetry, a way of folding the triangle in half. And so what I want to do is I want to make sure that when I fold this triangle in half, that the 2 equal sides fold on top of each other. And in doing so, that means angle A and angle B will also be the same measurement. Those are going to be the 2 equal angles for the isosceles triangle. So based on our conversation about the sum of the angles of triangles, if I take the 3 angles and add them together, I get 180 degrees. So that means the A angle and the B angle have to add up to 140 degrees. If I take away the 40 degrees from both sides, get rid of the 40. Now the A angle and the B angle happen to be the same measurement. So we could, so basically what we're looking for is, so what number does A have to be as well as B for the same number to be 140 degrees? So we could take the 140 and split it in half, since both angles have the same measurement. So both angle A and B would be 70 degrees. For triangle L, same thing. We have an isosceles triangle, and we're looking for that way of folding that triangle in half so the equal sides fall on top of each other, which means that these 2 angles here would fall on top of each other. So angle A is 50 degrees. So you have a 50-degree angle that's given. A is 50 degrees because of the line of reflection. And then angle B is the 3rd angle. So these 3 angles here have to add up to 180 degrees. So the 2 angles that we know, so they add up to 100. So angle B itself would have to have a measurement of 80 degrees. Now we've talked about in this GeoGebra activity that an equilateral triangle has 3 equal sides, 3 equal angles. An isosceles triangle has 2 equal sides and has 2 equal angles. The triangle we have not talked about yet is what happens if we have a scalene triangle. By definition, it has no equal sides. So if we constructed this and would look at those angles, how many of the angles in this triangle should be equal to each other based on what happened with the isosceles and equilateral? We'll continue our discussion on triangle angle sum rule next week. If you have any questions, please ask.